Okay, these are Chapter 3, Section 3 notes, Part 2. After going through the simulation that you're supposed to do before these notes, you should have a little bit better idea of what a mole is. It's basically a counting number. Everything we deal with in chemistry is so small that they made a mole to stand for 6.022 times 10 to the 23 of something, usually molecules, atoms, particles. But to compare it to something you already know, when somebody says dozen, they mean 12, right? Well, when you say mole, you mean 6.022 times 10 to the 23. If I had a mole of eggs, I would have 6.022 times 10 to the 23 eggs. That's a lot of eggs. And that's the same example that they used in your simulation. Okay? Both of those are vocab words, so you should already have them in your vocabulary. All right. The other thing we need to talk about is molar mass. The molar mass is right here. Let me show you where to find the molar mass. Okay. The molar mass is the decimal on your periodic table. So 39.098 is the molar mass for potassium. Okay. 22.990 is the molar mass for sodium. Okay. So that's where you find the molar mass. The units for molar mass is grams per mole. Okay, and here is the units. I would probably, in your notes, you are going to want to write molar mass is usually written in grams per mole because that is how we write it and that is typically how it is written. So make sure that you put this in your notes. Okay, so we are also going to use it as a conversion factor. I will show you that in just a second. Oh, well, here we go. As a conversion factor. Like again, I will show you that when I do your example problem. All right, so let's go ahead and get to our first example problem. All right, we're going to be back to using our dimensional analysis to do this. So this is one of the reasons that we learned how to do dimensional analysis, so we could work problems like this, okay? So, and here's our sample problem. What is the mass in grams of 3.50 moles of copper? All right, we're going to start these just like we did our other ones, and we're going to take what we're given, 3.5 moles, and we're going to put it in our first box. 3.50 moles. Use MOL when doing an abbreviation for moles because M is meters, and so it gets confusing. So use MOL. And then we always need to write the element that we're dealing with in our units now. Okay, so anytime we're doing these, you need to carry this element because if you need the molar mass, you need to know which element to look up. So carry the element given. All right, take our given and put it in the first box. Now, just like before, when we did dimensional analysis, we take whatever unit is here. In this case, it's moles of copper, and we put it down here. Moles of copper. Same exact thing, and it lets it cross out. All right, we are needing to go to the mass in grams, okay? Now, let me show you our conversion factors. The two conversion factors that you're going to use when working these problems is either in 1 mole, there is, this would be the molar mass. So when it says mass in grams, the reason there's not a number there is because it depends on the element, okay? Like I showed you on your periodic table a while ago, if we were dealing with copper, which we are right now, this would be the molar mass, 63.546. Okay, so it depends on which element you're dealing with. That's why it just says mass. That can be different numbers, but it is 63.456 in 1 mole, grams in 1 mole, okay? The other conversion factor that we're going to use is in 1 mole. There is 6.022 times 10 to the 23, and the units can be different here, atoms, molecules, particles. So these can be different units, but if you're doing mass, it's always grams, okay? Now, you don't have to use these conversion factors exactly like they are. You see it says 1 mole over mass in grams. You also can flip them around, and you can say, or you can take your mass in grams and put it over 1 mole. Okay, they can go either way. These are just basically the same. You can use them both ways. Same thing over here. You could do 6.022 times 10 to the 23. And I'm just going to do atoms, but hopefully it could be any of these, molecules, particles, doesn't matter, over 1 mole. It's the exact same thing. We can use these conversion factors any way we want to. Okay, so let's put that into motion. We started with moles of copper in our sample problem, and they wanted us to go to grams. So you should be able to realize that that means we would need to use this conversion factor. So here we are, we're in moles of copper, and I just looked at my conversion factors, and I know that I can go from moles of copper to grams of copper. And the way I do that is with the molar mass, okay? So look, here it is. There's my conversion factor set up, grams to moles. Well, I'm going to put a 1 in front of the mole because that's what it says right here. Right? There's a 1 in front of the mole. Now I just need my mass. Depends on the element. Well, I have copper, so it's 63.546. That's where that comes from. So 63.546 equals. We do these just the same as we did before. The bottom would just be 1. 1 times 1. The top would be 3.50 times 63.546. All right. 222. Okay, when you're writing your final answer, you would need to put 222 grams of copper. Those are your units, so it's important that you write it like that. All right. Sorry, I will take that off of there. All right, the answer is down here, so we will check it. Should be 22 grams. And you guys, you need to be working this along with me, even as far as putting it in your calculator so that you can make sure that when you get these, you can do these types of problems, okay? All right, there is the answer. That's what we got. We're good to go. Next example. A chemist produced 11 grams of aluminum, okay? 11 grams is our given. Aluminum is our element. They want to know how many moles. All these start the same, just like your other differential analysis problems. You need to start with what they give you, which is 11.9 grams of aluminum. You got to carry those elements, okay? Put it in your first box, okay? Whatever's here, whatever unit's here, put it down here to cross out. Same process. Now this time we're in grams. They want us to go to moles. I can go from grams to moles because I have a conversion factor that lets me do that. And then again, we're going to use this one. Like I said, it doesn't matter how you flip it, but we're using the mass to moles conversion factor. And to use that one, we just put a 1 in front of the moles, and we need to look up the molar mass of aluminum. Aluminum's molar mass is 26.992. Okay, 26.992. 26.992. There you go. All right, that's how you use that conversion factor. So on the top, you're going to have 11, because 11.9. 11.9 times 1 is just that, and then 1 times 26.992. and then divide them. So 11.9 divided by 26.992. All right, it would be 0.44, it should be 3 sig figs, so 0.441, and that would be moles of aluminum. Make sure you get all of your units there, okay? All right. I think we have 2 more sample problems because we haven't done one with Avogadro's number yet. So, so far you've got one for mass going both ways. And the next one that we will do is going to be with Avogadro's number. And this time I'm doing these straight on the slides because your problem's right there. So it may take a little bit longer to switch, but I think it's the best way. Try to get that to go away. But it won't. Lovely. Okay. There we go. All right, just to check, we did get the right answer. We're good to go. All right, so this is going to be the first one that uses Avogadro's number. But still, same process. Take what you're given, 3.01 times 10 to the 23. Atoms is your unit, and put it in the first box. Okay? Whatever unit you have here, atoms of silver, sorry, I'm just going to add this up here, silver. You put it down here so you can mark it out. Atoms of silver. Okay? They want you to go to moles. I can go from atoms to moles because I have a conversion factor. My conversion factor, see, that's why I put atoms over here. It can be atoms, molecules, particles, any of those. In 1 mole, there's this many atoms. So that's what I use over here. In 1 mole, there is, let's try to fit this in here, 6.022 times 10 to the 23 atoms. All right, when you're working this out, you would, this times 1 is just itself, so 3.01 times 10 to the 23. Down here, it's just a 1, so it's going to be 1 times this, so it's just itself, 6.022 times 10 to the 23. Remember when you put this in your calculator to use the EE button. Okay, so I'll put the top, 3.01 EE 23 divided by 6.022 EE 23. Okay, so I divided the top by the bottom, and you should get 0.3, I guess we would round that to 5, so 0.500 if we're rounding to sig figs, moles of silver. I know my writing is a little off, sorry. Make sure you include the units with these. Okay. All right. That should be good. I still have, okay, actually, there's one more. I have one more example problem to show you. And so far, we've gone to grams to moles, moles to grams, and then we just did atoms to moles. You should be able to do moles to atoms just almost the exact same way. You would use that conversion factor with Avogadro's number. The last one I'm going to do is, you know, kind of like the 3 steps when we were using the SI prefixes. It would have been 3-step problem. So you can't go straight from atoms to grams or straight from grams to atoms, okay? Because we don't have a conversion factor that lets us know how to do that. If you'll look, our conversion factor only goes grams to moles or moles to atoms. There's nothing on here that lets us go straight from atoms to grams. So all that means is that you have to go to moles in between in order to do that, okay? So the last example problem we're going to do is one like this. They want to know the mass, and they're giving you atoms. You're still going to start it like you did all the other ones. I know I'm going to scooch over here a little bit. It's going to be 1.20 times 10 to the 8, which is our given, atoms of copper. Okay? And you put that in the first box, as always. That's our given. Whatever units are here, put them down here. I'm leaving myself some room because I know I got to put a big number in there. Atoms of copper. All right, that's a U. That's copper. Now, right here is where you have to think a little bit because you're in atoms and you need to go to grams. I cannot simply just put grams right here and go straight to grams. I don't know any numbers to put there. Okay, I have to go to moles first, because that is what my conversion factors give me. Okay. I only know how many atoms are in a mole. I don't know how many is in a gram. So I'm going to go in 1 mole of copper, there are 6.022 times 10 to the 23 atoms. That's our conversion factor we just looked up on the other page. Okay, well, now I'm in moles of copper. I'm not into grams yet, so I'm going to go one more box. This unit will go down here to mark out. And now I can go to grams of copper because I have a conversion factor that lets me. And in 1 mole of copper, we just looked this up a while ago, but just to make sure. Okay, in 1 mole of copper, there is, right here, 63.546 grams of copper. 63.456 grams of copper. All right. You would equal, draw your line out there. Okay. The bottom number would just be 6.022 times 10 to the 23. That's all that's down here. The top one, 1.20 EE8 times 63.456 is a huge number. You can put it in scientific notation though, 7.6 times 10 to the 9, okay? And then divided by the bottom number, 6.022 E23. And your answer should be 1.26 times 10 to the, that's a 10, negative 14. And your units would be grams of copper, because that's what we were going to.